Let's discuss about the very important reaction that is called the Reimer-Tiemann reaction. Here what happens when phenol is which is going to be refluxed with the sodium hydroxide and chloroform, that is called CHCl3 at 330 Kelvin, 333 Kelvin, we are going to obtain the sodium salt of the salicylic and which on further acidification with the dilute hydrochloric acid we are going to obtain the salicylic. So let's take a reaction here. So here we are going to first take this phenol compound. First, this phenol compound which is going to react with the sodium hydroxide. So what we are going to obtain? Yes, that is very important. That is called sodium phenol. You know this one, sodium phenol. It is called O minus Na plus. This is called sodium phenol. What we are going to remove here? So when this Na will come here, so this hydrogen and this OH, which should be going to element, it is called water molecules. We are going to element here. So this is called sodium phenol. Which on further treating with this chloroform CHCl3 at 333 Kelvin. What we are going to remove here? We are going to remove the compound called so here. So hydrogen from this ortho position and this CHCl3. So I am going to write like this CHCl3, right? Cl3. Because of the carbon is tetravalency. So here I am going to remove this one hydrogen from this ortho position and this is Cl. So I am going to eliminate the HCl, right? So what is the remaining? I am going to write here. So this will be as it is ONA, this is sodium phenate plus in the place of this hydrogen I am going to take this when hydrogen and this chlorine which will be element here. What is the compound, remaining compound? CHCl2. This will be going to attack at this position because at ortho position carbon will be there. So when the C plus, when this after this losing the Cl, because the Cl is more electronegative than this carbon which elements as a Cl minus, right? So this carbon cation will be there. Carbocation will be formed here. This carbocation with carbonate which makes this new bond, that is called CHCl2. This is called an intermediate compound. What we are going to remove here? Here Cl minus and this H. That is called, we have removed the HCl compound. So next, which is going to further react with the two molecules of the NaOH compound. Two molecules of the NaOH compound. What happens? So at the position of this 2Cl, I am going to write like this. CHCl, right? So here two hydroxide group will be there from sodium hydroxide. These two OH group will be attacked here. This at the position of the Cl, and we are going to remove the 2Cl minus and 2Na plus. That is called 2NaCl. I am going to write as it is. So this will be as it is sodium phenate, and here carbon with hydrogen. At the position of the 2Cl, I am going to take with the hydroxide ion 2OH group. So what is the left here? 2Na plus as it is will be there, 2Na, and we are going to remove the 2Cl minus, that is called salt. So 2 molecules of the sodium chloride salt. So this compound is formed here. And here from this compound we are going to remove the water molecules. So like this, we are going to remove the water molecules. When you remove these water molecules, what happens here? When you remove these water molecules, we are going to obtain the sodium salt of the salicylaldehyde. Salicylaldehyde. We are going to obtain the iodine group. Iodine group is nothing but the CHO group. So when this hydrogen takes place, we are going to obtain the CHO because OH group will be eliminated and hydrogen will be eliminated. What is left here? This carbon, hydrogen, and remain double bond both. That is, I am going to write here. What we are going to remove here? Water molecules I have removed here. So we are going to obtain the sodium salt of this remaining as it is will be there, the sodium phenate, sodium salt of the aldehyde, that is called CHO. What is the remaining? When you remove this water molecules, what is left here? CHO. This is called sodium salt of the salicylaldehyde. Use the sodium salt of salicylaldehyde. Salicylaldehyde, which on further acidification with dilute sulfuric acid, that is called HCl, we are going to obtain the salicylaldehyde. That is, this OH will be as it is will be there, and this will be the CHO compound. What I am going to do here? So this H plus will combine at this position. That is in the place of Na plus, this Na plus and this Cl minus, which will be going to eliminated here. When you remove this Na plus Cl minus, so here this Cl compound from the dilute hydrochloric acid. This is Cl minus and this Na plus. We are going to remove the salt. And what is the left here? H plus. This H plus will come and attack at the sodium position. So this is called as salicylaldehyde. This is called salicylaldehyde. This name is called salicylaldehyde. So like this, this reaction starts from the phenol, which is going to react with this sodium hydroxide. We are going to remove the water molecules. This is called the sodium phenate ion. So this sodium phenate ion, which is further react with the chloroform at 330 Kelvin, 33 Kelvin, we are going to remove the one chlorine atom. Because of this electronegativity parameter, it gets the carbocation. This carbocation, and here the other position carbon will be there. So here it makes the bond. I mean, this acts as electrophile here. This electrophile will come and attack here. When this happens, this hydrogen from the ortho position with the Cl minus we are going to remove here. It is called HCl we have removed. What is the remaining here? O Na as it is at the position. This CHCl2 will come and attack here. And when you are going to use the excess of the sodium hydroxide, these two OH group will be attacked here. In the place of the Cl minus, we are going to remove the 2NaCl. After this compound, we are going to remove the water molecules in order to make the compound called the sodium salt of the salicylaldehyde. We are going to obtain the CHO compound. So when you remove the when this reaction further which undergoes the acidification in the presence of the dilute hydrochloric acid. So in the presence of the chlorine from the hydrochloric acid, which will be going to react with this Na plus to remove the sodium chloride, and we are going to obtain this salicylaldehyde. Let us discuss about the last chemical reaction, that is called acetylation of the phenol. Acetylation is nothing but introducing the acetyl group towards this benzene ring, that is called acetylation of the phenol. Let us take an example for this reaction. I am going to take the example as acetylation means we are going to use the acetyl chloride or acetic anhydride. So I am going to take this phenol compound. This phenol, which is going to be treated with the acetic anhydride, its name is formula is CH3 C double bond O C double bond O CH3. Its name is called acetic anhydride. So whenever we are going to use the acetic anhydride in any reaction, one thing we should keep it in our mind that we are going to remove the acetic acid, that is called CH3 C double bond O. This will be eliminating here, and remaining this electrophile will attack here. So that's why in this reaction I am going to use the pyridine compound. Pyridine here it acts as a catalyst also, and because to remove this hydrogen from this phenol, so here this hydrogen and this CH3CO that becomes the acetic acid. I am going to remove the acetic acid CH3COH. CH3 C double bond O H it elements here. What is the remaining compound? That is called phenyl acetyl to be formed. That is called, what is the left here? O. Then it is linked with C double bond O CH3. This is called phenyl acetyl group. Its name is called phenyl acetyl group. Because of the introducing the acetyl group towards the phenol compound, that's called as phenyl acetyl. So here we are going to remove the from the acetic anhydride, we are going to remove the acetic acid CH3 C double bond O H. Here we have removed the acetic acid. Remaining compound is O with this C double bond O CH3. So like this we are going to obtain the phenyl acetyl. So let's take one more reaction as the salicylic acid. You know the salicylic acid. So COH and this OH group, it is going to react with same acetic anhydride only, CH3 C double bond O C double bond O CH3. What happens? Same. We are going to remove the acetic acid only, CH3 COOH. This salicylic acid, when it is going to react with this acetic anhydride, we are going to remove the same, that is called acetic acid CH3 C double bond O H. Here, what is the remaining compound? You should write here C double OH O with C double bond O CH3. Its name is called aspirin. Its name is called aspirin. Also acetyl salicylic acid. We are going to call acetyl salicylic acid or aspirin. So like this, introducing this acetyl group into phenol, that is called acetylation of the phenol.